The second to last topic we're going to talk about is the arc length. In order to find arc length, we do similar to how we found sector area, except now, instead of using area, we're going to use the circumference. So we're going to have, again, our x over 360 part times our circumference, which could be 2 pi r or pi d, depending on what they give us. So let's take a look at this first guy here. We have our x, again, which is our degree or our piece. So here my piece was 100 over 360. We're looking for minor arc BC, so that helps us out, times 3.14 times 4 squared. So we type that directly into our calculator. And I get 13.95, which rounds to 14 as the, oops, sorry, that's incorrect. I did the area. Okay, I just need to do 2 pi r. So there's my pi, 2 times the radius. So I have 2 times 4 times 3.14 times 100 divided by 360. And I get 6.97, which rounds to 7 for BC, the length of BC. Okay? So this piece right here is 7. And again, we can check by finding the total circumference. So the total circumference would be 2 pi r equals c. So we want to do 2 times 3.14 times 4, which gives me 25.1. And if I were to take 25.1 and divide it by roughly 3, because 100 is roughly a third, I get about 8.3, which is pretty close to 7. This isn't exactly a third, so that is why it is a little less. This is less than a third, so it should have a number less than. So our answer makes sense. This time we're trying to find the major arc of BCD, so BCD here. So we got to find our x piece. We got to do a little bit more work on this guy. Well, we have this box here, so we know that this guy is going to be 90, so that our x is actually going to be 190 over 360 times 2 times 3.14 times our radius, which was 5. And when we do that, we get 190 divided by 360 times 2 times 3.14 times 5, which gives me roughly 16.57, which is 16.6 for that arc. And that is how we find the arc length of a circle, or partial arc length.